Hello and welcome to our lesson on calculating values using negative indices. Today, we will explore some intriguing concepts that will deepen your understanding of powers and roots, enhancing your mathematical skills. In this lesson, we'll build on our knowledge of indices by introducing negative indices and learning how to work with them effectively. Our primary focus will be on understanding and applying these concepts. We'll start by defining negative indices and understanding what they represent. Next, we will explore the rules for calculating values using negative indices. Finally, we'll run through some examples to apply this new knowledge in various contexts. In our previous lessons, we've established a strong foundation by discussing integer indices and working with whole number powers and understanding their properties. We have also looked at fractional indices. With that solid understanding, we are ready to delve into negative indices. This technique is essential for addressing scenarios where the indices are not positive, enabling us to simplify and solve a broader range of problems. Before we delve into negative indices, let's quickly review some fundamental concepts. First, we have indices, which are also known as exponents, which represent repeated multiplication. For example, a to the power of 3 means a times a times a. Then we have some laws of exponents. Our first law is that a to the power of m multiplied by a to the power of n equals a to the power of m plus n. Our second law is that a to the power of m divided by a to the power of n equals a to the power of m minus n. And finally, a to the power of m to the power of n equals a to the power of m times n. Make sure you are comfortable with these basic rules as they extend to negative indices too. Now let's look at negative exponents. When we have a negative exponent, it means we take the reciprocal of the base raised to the corresponding positive exponent. This might sound confusing, but what it means is that when we see a negative exponent, we know we need to find the reciprocal. The reciprocal just means that we put the number a to the power of n on the denominator and put 1 on the top. So the rule is shown at the bottom here and states that a to the power of negative n equals 1 over a to the power of n. Let's go through some examples of negative indices to understand this better. Suppose we have 2 to the power of minus 3. Step 1 is the recall our negative indices rule. We can then use this rule to convert 2 to the power of minus 3 to 1 over 2 to the power of 3. We can then calculate the denominator by doing 2 to the power of 3 equals 8. Therefore, the answer is 1 over 8. Let's look at another example. Calculate 5 to the power of minus 2. First, recall the negative indices rule. Use this rule to convert 5 to the power of minus 2 to 1 over 5 to the power of 2. Now calculate the denominator, which is 5 squared, which equals 25. The result is therefore 1 over 25. Let's look at a slightly more complicated example. Calculate 2 over 5 to the power of minus 3. First, we know that a negative exponent means that we need to take the reciprocal of the base and then raise it to the positive exponent. So in this case, the base is 2 over 5, so we need to take the reciprocal of that base. The reciprocal of 2 over 5 is 5 over 2. We then need to raise this to the same exponent as the original question, but now it becomes positive rather than negative. So we get 5 over 2 to the power of 3. Now we can calculate 5 over 2 to the power of 3 by cubing both the numerator and the denominator. So 5 cubed becomes 125 and 2 cubed becomes 8, giving us 125 over 8. This is our final answer. If we want to write it as a decimal, then we can put it into our calculator and the result is 15.625. Now, let's establish the relationship between negative and positive exponents. What happens if we do it to the power of n multiplied by a to the power of minus n? Well, using our law of exponents, we know that we need to add the two exponents together. This gives us a to the power of n minus n. Notice that they are subtracted here because the negative n cancels the plus out. When we do n minus n, we just get 0. Therefore, we get a to the power of 0. Mathematically, anything to the power of 0 equals 1. So we get an answer of 1. This shows that any number multiplied by its reciprocal yields 1. This connection is a useful check for your calculations. Some common errors to watch out for are misinterpreting the negative sign as subtraction rather than an exponent indicator, failing to correctly calculate the reciprocal. Now some strategies to avoid mistakes. Carefully write out each step. Double-check your calculations. Practice consistently to build confidence. Let's dive into some walkthrough examples to see how we can tackle GCSE level questions involving negative indices. Let's look at an example. Simplify 2 over 3 to the power of minus 2. Pause the video here and try this out. First, use the rule for negative indices and flip the fraction so 2 over 3 to the power of minus 2 becomes 3 over 2 squared. Next, calculate the power by squaring both sides of the fraction so 3 over 2 squared becomes 9 over 4. So 2 over 3 to the power of minus 2 equals 9 over 4. Let's look at another question. Simplify x to the power of minus 3. First, recall the rule for negative indices. Then use this to simplify our example. So x to the power of minus 3 equals 1 over x cubed. We don't know what x is, so there's nothing we can do to simplify this further, and that is our final answer. Now for our third example, simplify 2 to the power of minus 3 over 4. Simplify the negative index first, so 2 to the power of minus 3 becomes 1 over 2 cubed, which equals 1 over 8. Next, substitute this back into the expression. So we have 1 over 8 divided by 4. Finally, using our fraction rules, we can simplify the fraction, and this gives us 1 over 32. Thus the answer is 1 over 32. Now for our final example for this lesson, simplify 3x to the power of minus 2 divided by y to the power of minus 1. First, recall the negative indices rule and apply this to both x to the power of minus 2 and y to the power of minus 1. X to the power of minus 2 becomes 1 over x squared, and y to the power of minus 1 becomes 1 over y. We can now substitute these back into the expression, so we get this. This might look confusing, but let's work through it step by step. We can start by simplifying the numerator by multiplying the top of the fraction by 3 like this. Then we can write this out as a division rather than a fraction like this. Now we can use our rules for dividing fraction to simplify this further by changing the divide to a multiply and then flipping the second fraction like this. We can then simplify this by multiplying the numerators and multiplying the denominators to get 3y over x squared. Well done. That was a hard one. These examples should give you a clear understanding of how to handle negative indices in various contexts. By practicing these types of problems, you'll become more comfortable with this concept and be able to apply it confidently in your GCSE exams. In today's lesson, we began by reviewing basic concepts of indices, emphasizing the laws of exponents, which laid the groundwork for our understanding of negative indices. We then defined negative indices, explaining that they represent the reciprocal of the base raised to the corresponding positive exponent. Through various examples, we demonstrated the step-by-step process of calculating values using negative indices. We also tackled more complex examples, including fractional bases, to illustrate the versatility of this technique. We also examined the relationship between negative and positive exponents, which reinforced our understanding of the reciprocal nature of negative indices. By mastering negative indices, we can simplify and solve a wider range of mathematical problems, enhancing our overall mathematical proficiency. Watch the rest of the GCSE Maths course at Sophos Education.